So this is a continuation of our previous video. I'm just going to continue to go over how to write and balance equations. Number 4 there that you can see that's already done was on a previous video. So if you don't understand how that was done, then feel free to watch that one. We're going to start with this one here. Remember from the previous video, if you watched it, I like to go ahead and write down my state scripts above the problem as I read it. So that way when I go back and double check myself, I can check to make sure I have the states, because I always forget them. And so while I'm looking at this, I have solid potassium chlorate, so that's going to be a solid, is strongly heated, so I'm adding some energy to it. It decomposes, which means it's going to break down to yield oxygen gas, so it's a gas, and solid potassium chloride. Now something else that it says is it tells you the hint, and that's because my oxygen gas here, if you remember, is going to be a diatomic, so I need to keep that in mind when I write it down. So now I'm going to write out my equation. So then I have potassium chlorate. And so potassium, if you remember, has a charge of +1. And when we use our polyatomic ion sheet, our chlorate is a -1. And so they already balance charge-wise, so I don't need to worry about adding any other subscripts. But don't forget your state script. So potassium chlorate is heated and decomposes to yield oxygen gas, it's my Brinkelhoff, that's my diatomic, plus solid potassium chloride. Potassium is a +1, chlorine is a -1, and so those balance out just fine. Don't forget your state script, so it's going to be a solid. So once again, we're going to write down our elements. So I have potassium, I have chlorine, and I have oxygen. When I count on my reactant side, I have 1 potassium, I have 1 chlorine, and I have 3 oxygen. On my product side, I have 2 oxygen, I have 1 chlorine, and I have 1 potassium. And so when I look at these, my potassium and my chlorine are already balanced, so I really just need to focus on the oxygen. And so what I notice is that my oxygen over here, while it has more on my reactant side, I notice that on my product side it's even. And so there's not going to be any way, because it's O2, there's not going to be any way for me to get that to be an odd number. So normally you work to match the higher number, but in this case, since it's odd, I'm going to go ahead and alter this one first. And so in order to do that, the easiest way to make anything odd and even is to multiply by 2. So let's keep it as simple as possible. We may have to go back and forth a couple times, but that's okay. In doing this, that now changes my oxygen from being a 3 to a 6, because 2 times the original 3 makes it 6. So I have that 3 right there. However, it messes with everything else as well. Now that gives me 2 chlorine, and it gives me 2 potassium, so it seems to have made a big mess, but it'll work out in the end. Because what we're going to do is, now that I have 6 oxygen on my reactant side, I'm going to keep working with the oxygen to balance it. And so I have 2 oxygen on my product side. Well, I know I need to multiply it by 3 to change it to 6. Then I need to get my product side, potassium and chlorine, balanced. So let's just focus on potassium first, because that's at the top. And so potassium, I had 2 on my reactants, so I want to put 2 there, so I have 2 on my products. Well, remember, it also impacts the chlorine, so the chlorine goes from 1 to 2. And once again, by focusing on things one step at a time, we managed to balance it just fine. The next one is solid titanium 4 chloride. So once again, we're going to put our state scripts. So we've got solid, reacts with water, water's going to be a liquid, to form solid titanium 4 oxide and aqueous hydrogen chloride. So titanium is going to be Ti, and we know that titanium has a charge of +4 because that's what the Roman numeral tells me. Chlorine is a -1, so to balance it out, that means I'm going to need 4 chlorines with 1 titanium. It says it reacts, whoops, don't forget my state script. It says that it reacts with liquid water, so H2O, which is a liquid, and that it's going to yield solid titanium 4 oxide. Titanium is 4, titanium is +4, oxygen is -2, so I'm going to need 2 oxygen to balance it out, plus aqueous hydrogen chloride. Hydrogen's a +1, chlorine's a -1, so they balance charge-wise, and so I just need to put my state script. So I'm going to go back through and check. Yep, I have all my state scripts, so I'm good. So now I can move on to the next part. So I've got titanium, I've got chlorine. I'm just going to write that down a little bit further. I've got titanium, I've got chlorine, I've got hydrogen, and I've got oxygen. And so now I'm going to count up what I have. And so to start, titanium on my reactant side, I have 1 titanium, I have 4 chlorine, I have 2 hydrogen, and I have 1 oxygen. On my product side, I have 1 titanium, 2 oxygen, 1 hydrogen, and 1 chlorine. When I'm looking at this, the only thing that's balanced is titanium. So I can really pick up wherever I want. I can balance whatever I want. Just as a general rule of thumb, I leave hydrogens and oxygens for last. They usually tend to be a little bit more complicated. By balancing out the other things, they usually just kind of fall into place. So since that's what I usually do, I'm going to continue to do that. So that means I'm going to start with chlorine. And so to get 4 chlorine on my product side, I need to put a coefficient of 4. That's going to change my chlorine. However, it's also going to change my hydrogen. Luckily, it didn't mess with the titanium, so everything's still okay. So now what I need to do is I need to balance my hydrogen. I could also balance the oxygen, it doesn't matter, but we'll go ahead and do the hydrogen. So on my reactant side, I have 2 hydrogen, and I need to have 4 hydrogen, so I'm going to put a coefficient of 2. By putting that coefficient of 2, that's going to change my hydrogen to a 4, and it distributes to the oxygen, so that's going to change my oxygen to a 2. And once again, by focusing on things other than hydrogen and oxygen, it kind of falls into place. Let's look at number 7, which I believe is our last one. So on this one, it tells me calcium carbonate, also called limestone. So that's going to be a solid. It doesn't tell us there, but I'm telling you it's a solid, limestone. Why did I put parentheses around that? I don't know. So solid decomposes when heated to produce calcium oxide. Oops. It doesn't tell you on this, so I'm going to tell you that it's a solid. And gaseous carbon dioxide. On a test, I would tell you that calcium oxide was solid and calcium carbonate was solid. So, going through here now, I'm going to write out my formula. I have calcium, which is a +2, and then I have carbonate. Sorry, I don't like how that looks. There we go. So I have calcium, and I have carbonate, which is CO3, and is a -2. So since calcium's a +2 and carbonate's a -2, the charges balance out already. And then I tell you that it's heated so that it decomposes, it breaks down into calcium oxide. Calcium is a +2, oxygen is a -2, and carbon dioxide. Now if you notice, I did what I tell you I do all the time, and I forgot my state scripts. So I'm going to go back and make sure I add those. So my first one was a solid, my second one was a solid, and my third one was a gas. Now I'm going to go ahead and write out the different elements. So I've got calcium. I don't know why I wrote it so close. I've got calcium, I've got oxygen, and I've got carbon. Remember, it doesn't matter what order you write them in. You probably wrote carbon first just because it came first in the reactant side. So I'm going to go ahead and change that just to try to follow along what you most likely did. But if you have it the other way, that's perfectly fine. So now, once again, we're going to start by counting the atoms on both sides. My calcium on my reactant side is 1. Carbon is 1. Oxygen is 3. On my product side, I have 1 calcium, I have 1 carbon, and I have 2 plus 1, 3 oxygen. Hey, we don't have to do anything with that one. It's already balanced. So I hope this helped. If I need to do some more examples or some more things, I certainly will. But this was just some extra practice for you to check and go along with, and to hopefully help things make a little bit more sense.